All right. Welcome, everybody. My name's Kate, and today we're going to talk a little bit about experiments. I'm going to make sure that everybody can see my screen. Everybody good? Staring at a Canva? All right, cool. So we're going to talk about how experiments bring us confidence. Confidence in how to move forward together. But experiments can often feel like slowing down. Should we slow down? Are we going to be comfortable slowing down in order to speed up? How will experiments and slowing down help us speed up? Let's talk about that. First, I wanted to introduce myself. I know I'm new to a couple people here. So my name's Kate. It's nice to meet you. I'm another Kate. You can call me Kate Mack. I've spent 10 years managing products and teams. It feels weird to say that, but that's the reality. I've worked at agencies. I worked with enterprise companies. I've worked with early stage healthcare startups, financial apps, the DoD, all these things. I've seen a lot of stuff happen in a lot of different ways, and I've learned some stuff. So now I'm a product coach. I've been coaching different teams, different companies for quite a while, but right now I am at Kaiser Permanente full-time, and I've been coaching and helping the coaching team at Sagely for almost a year now. So it's nice to meet everybody, and I'm happy to answer questions about my background or talk more about some of this stuff at the end. I've got some time and space for questions too. Cool, let's keep going. So experiments, I happen to believe they're awesome. I'm going to show you all my cards up front. I love them. And we're going to talk about why I think they're awesome. So they help us explore ideas. I know you can read this, but I'm going to call out these pink words: exploring ideas, validating assumptions. We're going to talk a little bit more about what that means, prioritizing the best solutions. I think sometimes everybody says they want to prioritize, but what that really means is they want to deprioritize. And then things that achieve our goals, and talking about what does that really mean? I'm going to check the chat. It looks like, okay, slow is smooth and smooth is fast. I love it. Okay, so there's a lot on this slide, but hopefully some of this should look a little familiar. We've got elements of a team. We've got folks who on the left-hand side are coming up with our goals and outcomes. These are like the North Star. If we're successful, this is what it looks like, kind of stuff. Then you have people who are breaking that goal down into a plan, into a roadmap, maybe even breaking that work down into some chunks and smaller things that an engineering team could build. We've got designers working on user experience, the sequence and flow of how all of this is going to happen in software. And we also have some engineers who are working on building this thing and turning our ideas into reality. All of these people are working in lockstep to make a team successful. And when we have a good plan, when we feel like we've got a solid plan, it can feel really weird to question it, to question the plan and kind of slow down or maybe even stop and say, is this the right thing? Oh, here we go. So here's the problem. Right away, our problem is that we, on this call, in this world, human beings, we are very, very smart. What does that kind of lead to? When we're working in one area or in one space, we become subject matter experts. We know everything there is to know. We're the most qualified. People come to us, looking for advice in this subject area, but we forget something huge. Our real problem is that we forget that we are not our users. So what does that mean? We talk about, our users are nowhere near experts like us. Their day-to-day job is not working in the space that we're working in. They have other things to do. They've got other goals, other outcomes. They have different perspectives. In this example, thinking about a team that works on a healthcare app for patients suffering from dementia, though that team probably knows a whole lot about dementia, the disease itself, the symptoms, treatments, how it impacts neurological and motor functions, helpful ways that family members can care for people who are suffering from dementia. But unless the team, anyone on that team themselves actually has dementia, there's a pretty low chance that they'll be able to predict the way that a patient with dementia will interact with their software. Like maybe they might not want to use clinical language. Or they may need some features that will save the user's place to handle disruptions in thought patterns, or if the user tends to step away from the software and then pick it back up later. At best, we can make assumptions about how our users experience the software. I want to look at these graphs for a moment. This is a bunch of reasons. There are two different data studies about why startups fail. The top 10 reasons why companies quite literally are spun up and then spun down because you know what, it didn't work. I want to call out, look at some of these areas on why startups fail. We're assuming too much about our customers and our market. We're like, well, I'm the expert here. I know what's going on. And in reality, maybe it's not going to be a hit with those customers. We think it's going to be. Our mom said that she liked our idea, but those people may not have connected with it. Or maybe there's something out there in the market that's addressing this problem already and you're too late, something like that. What do these really look like? I have some examples. So you may have heard of some of these companies. It's totally okay if you haven't, but whether it's a new startup or an existing organization, if you don't continue to connect and validate these assumptions that you're making, oh, no one will ever need to access digital movies at home. They will always be okay driving to the store and picking up a movie. You know, these kinds of assumptions are business ending, funding ending, team ending. So we need to get on top of these assumptions. I'm going to repeat myself. We make a bunch of assumptions about how everybody's going to experience our software and about the plan that we have and what's in prioritization, what's in order of highest priority to build next. But these assumptions, they're assumptions. They can be and often are wrong. So when we talk about experiments, this is the 1, 2, 3 punch here. I'm not going to totally read everything to you, but up front, we're going to make some hypotheses, some educated guesses. We've already done that. We've got our plans. We think we know what we're going to work on. And then we're going to test those ideas. We're going to figure out how can we validate the assumptions that we've made here and be sure that this is the right idea. And at the end, we're going to prioritize what works and change what doesn't. Sometimes it's changing it. Sometimes it's trashing it. Sometimes it's pivoting into a new space. Let's break this down a little bit further. But before we break it down further, I want to address something. When we test this stuff and it doesn't work, it's actually not failure. We don't need to be afraid of this, of the idea of experimenting, because failure is more like learning, right? I think it's only failure if we don't adjust the plan. We failed if we tested it, we figured out it was wrong and we didn't change anything. That's failure. But testing yourself early is smart. Let's look at an example of a real team with a goal, a plan that they need to test. So this team, the Rocket team, needs to solve a big problem. They have schedulers. Their users are schedulers that are submitting these schedule forms here on the right-hand side. They're not submitting the forms anymore. They're not getting a steady stream of forms being submitted. They think what's happening is that these users aren't realizing that their form fields, all of these form fields are required to submit the form. Right now, they're skipping some of those fields, and you see at the bottom, there's this error message that they're getting when they try to submit the form. They're unable to do it. So they get confused, maybe they abandon it. This is what we think is happening, and it's not good. We need to fix this. So what are some options for solving this problem? They think of some solutions. On this, number one, what if we visualized these fields and said, okay, all of these are required. This is a common pattern in UI, right? We'll stick an asterisk on it, and that way they'll know. Number two, disable the submit button. Sometimes you'll see a form where if you haven't filled out what's required, the form won't let you hit submit before you move forward. Number three, what if there's this modal, this pop-up that happens that says, hey, these are the fields that you missed. You're going to have to go back and fill them out. And then number four, there's another idea about inline error validation. Sometimes this can happen before they hit submit. This is like if they click into the field and then they still skip, or they hit tab, something like that. Sometimes this could happen upon hitting submit, and we could show this. These are their ideas that they came up with, but it doesn't really make sense to build all of these things. There's a lot of work, and we're just trying to solve a problem. This isn't even new functionality. We're just trying to fix the fact that our form isn't working. So option one, it's helpful, but they're still going to get an error if they submit. But this doesn't change the experience much besides showing visually which fields are required. This second one prevents them from sending the form, but will that be enough to help them understand why? We're kind of already preventing them from submitting the form with this error message. Options 3 and 4 can't even coexist with option 2. If we're letting them hit submit, like this stuff wouldn't have a trigger to show them visually what they've missed. So should we just pick the option that we like the best and move forward? Like, what about the boss's opinion? Maybe the designer is like, good ideas, team, but I want to move forward with this one. What if we, instead of guessing, what if we refocused on the problem itself and it was like, okay, what about the fact that this form's not getting submitted and we have a hypothesis that it's because they don't understand that these fields are required. Let's try to run an experiment. So steps for an experiment. This is like, hopefully you can take this away. So outlining the goal, getting clear. What is the problem we're trying to solve? What is the outcome that we want to get to? Making a bet, picking a couple options for how to solve that thing. Testing, is it this one or this one? A or B or C or D. The options could be endless, but again, more options equals more experiments for you. So get smart about which bets you're making. Craft your plan, figure out how could we test these options that we have? What's the way that we're going to do this? How will we present this to who? And what are we going to measure to know which one works? We'll run the test, execute the experiment, figure out which option with real people who are not on our team. We need to go talk to real people out in the field who would be using these solutions. Come to a conclusion, figure out what did we learn, and then move forward with confidence in the thing that we have decided to go with. Here's what they tried. So we need people to understand our form. We think that visualizing which fields are required before and after submit is going to work. We can highlight which ones they've missed. And then we're going to schedule some usability tests with these designs. It's just the designs. We haven't coded anything, just the images. And we want to measure which design will help these folks figure out which required fields they've missed the fastest. We want this to be simple, easy. We want them to be quickly understanding that I missed that, I'll fill it out and I'll send the form. So they've got this hypothesis down there. That's the same thing, but just worded a little bit like the scientific method, right? We believe that by presenting these required fields, which ones are required before and after hitting submit, will help them submit the schedules, and we'll know that it's successful when they can identify the fields in like 10 seconds or less. It shouldn't take them much longer than that. Here we go. They scheduled 10 15-minute sessions with users. The designer, introduces herself. She asks, can I record this so I can focus on the conversation and not have to take notes? Great. I know a lot of you have already just been talking about user-centered design in the latest conversation. So this should be making some connections, right, with some of the stuff we've already been talking about. They showed this form. This is the form as it is today. They just asked, hey, could you tell me what each field is asking for? And let's see if they understand that some of these fields have been skipped. Let's see. Let's just figure out, do they understand what's going on in the form before we even get to needing to submit it? Next, they reviewed the same form, but with some asterisks to see, did they notice the asterisks? Did they realize that there's an asterisk on every field? Next, they disabled the submit button and asked them like, hey, what's going on now? Did they understand they couldn't submit the form? Did they know why? They showed them the design with the modal. How do they react? What's going on here? Did they understand what to do next? Was this clear? And then last, they showed them the inline validation. How do they react to this? Did they understand what to do next? So here's what they learned. This first one with the asterisk, it was mostly invisible. They didn't really see it. It didn't really, generate a lot of interesting conversation here. One person did say, wait, so every field's required? That was news to them. Next, the disabling the submit button. People were mostly mad. People were kind of like, I hate it when that happens. I hate that. It's unclear why they couldn't move forward. And it was just a little bit, it's like disheartening before they even try something. The alert modal. It was easy for them to say, oh, I was missing those fields. Everybody was able to kind of say, okay, those are the fields I missed. But once they closed it, they weren't sure again which fields were required. There was a little bit of a disconnect there. The last one definitely was the easiest for them to figure out which things were missing, both before and after hitting submit. They didn't have any trouble identifying that these fields were required, but a couple people shared an interesting insight. More than one person said, hey, I won't actually know the departure time when I'm filling out this form. It's pretty early in the process when I send this, so I don't really know when the schedule should have it departing. At first, everybody was like, what do you mean? Of course you need to know the departure time. It's a scheduling form. This is wild. They knew that they would have to have departure time eventually. They were like, we can't remove the field. Our leadership will never let us remove this field. And it shouldn't be optional either. It has to be required. This is a scheduling form. So Jennifer, the designer, decided to dig in a little bit more and ask why. She was talking to them about why, what do you mean you wouldn't know this? It was a little bit riffing off the experiment plan, but she was asking why to get to what's going on with this departure time. They said that they would know generally what time of day by the time that they would submit the form, but they weren't sure about whether that departure time would change. It sounds like it likely changes a lot after this form is submitted. So they would end up hesitating to send the form at all because they weren't sure if there was a way to change it later. So overall takeaways from this experiment, they learned that with this design, these schedulers could figure out what was missing in 10 seconds or less. They used the asterisk design and the inline validation. There was no need to do the disable button feature and no need to build in that modal that listed out all these required fields. They also concluded that maybe people would be more likely to fill in that departure time field if it prompted them to select a time of day instead of an actual time, due to the ambiguity with the reality of their process. So now that team can move forward with their solution, and they didn't actually have to code anything to know for sure. There's a chance that their engineers may not have had to take any time away from active development to run this experiment. That said, it's always a great idea to include engineers in experimenting because engineers are really good at coming up with options and ideas for ways to solve problems. And once we learn something, it's great to bring them in too, because they're the ones who are going to build it. That when engineers have context in why we're building something, usually ends up with just great results versus like, now every time a new thing hits the backlog, you need to explain it to me. I wasn't part of the genesis. So last point here, designs or solution ideas, like we're talking about no code necessary, right? You don't even need digital wireframes. This could be something like a sketch on paper. I'm going to show you what I mean by that. This was a real design from a team at Kessel Run. An airspace team was working on what if we set up a request form that someone could fill out, and then instead of a person manually having to check for conflicts with the airspaces, what if the system did it for them? This was in concept mode, right? We weren't really actually ready to build anything, but we took this piece of paper, we were testing a few things with this, and we put it in really physically in front of a person. We showed them this first piece of paper, and we were testing, would this be confusing if they only saw one field at once? Did they understand what each field was? You can see in the second image, each field that we had them fill out was something separate that we put in front of them over the test to see if they were understanding what each field meant. And then the third option, we wanted to see, before we showed them what a potential conflict report could look like, we wanted to ask them, what do you think is happening when the system is checking for conflicts? We were just wondering, would they get it? Would they understand here? Because this was a brand new idea. And then finally, this last example, we were saying, we were testing to see, would they trust the system to recommend the conflict resolution and enough to hit accept and just keep moving or not. This was really cool, and it was just paper. I know there's some other teams out there that are also working on hardware. So when we talk about software, it can be a little bit different. I do have a story. I worked with someone who had this idea on the left-hand side. You may have seen this before, a box that is like a UV sanitization for phones and keys and things. They had this idea. It was a pharmaceutical, like a healthcare company. They were like, what if we built a box like that for medical professionals in between services with patients to stick their hands in and, sanitize themselves without having to use any product or water or soap or anything like that. Instead of building this box and then going and testing it with people, they basically painted a shoebox and took it into a hospital. And they told the nurses that this would actually sanitize their hands. It didn't. There was a little light on, I think, that they had put in that when it was like motion sensor, that light would stay on for 30 seconds or so. And they just said, would you mind using this today with your patients, in between patients, to see if they would. They just wanted to see if the nurses would stick their hands in there and trust it, and if they would stay the whole time for the 30 seconds. They learned quickly that the nurses weren't going to have the time and space to do that. They weren't as comfortable with this technology. It wasn't the right time. They didn't end up building the box. But could you imagine if they had built the box and then the nurses didn't use it anyway? Like, wow, this is why we do these experiments. So back to this sentence. Hopefully it makes a little bit more sense now. Experiments help us explore ideas, validate the assumption we're making to prioritize solutions that actually achieve our goals. Here's 2 visualizations of like science graphs of why we do this. I want to talk about risk and how much risk we build up over time while we build stuff. So when we build things, we build up assumptions. When we don't check and validate our assumptions, this risk builds up and up and up and up. When we actually check our assumptions, that's when we learn whether or not we were right. If we were wrong, we have kind of a far way back to where we started to have to redo, undo, roll back, those kinds of things. Similar chart with knowledge, how much we know over time. So if we build and we build and we don't check ourselves, we're not learning anything new. We're not starting at 0 knowledge, but we're not learning anything new. So when we actually do check ourselves, when we release something, we learn a whole lot. Same thing. If we're wrong, it's kind of painful to have to go back. What if we validated assumptions little by little? We built some stuff and then we checked ourselves. We built stuff and kept validating ourselves. If we were wrong, we only have to go back a little bit. There's not a ton of risk that we've built up that hasn't been validated or mitigated. On this side with knowledge, asking questions, getting answers early and often, we're learning a little bit over time. And if we're wrong, again, we just have to go back a little bit. So this is great. This is obviously very cool. Why don't people experiment all the time? Why are teams not doing this constantly? Remember this, it can feel like we're slowing down this big machine when we start to question things. And there's often not space in our plans built to manage ambiguity. Sometimes folks aren't okay taking time away from development for discovery. And then remember this, sometimes it can feel strange to question ourselves. Aren't we subject matter experts? Why are we questioning our plan or our priorities when we know what's best? Someone at some point, probably on the left-hand side, made a plan. Are we actually empowered to question their plan? And then also, do we have access to users? That's a huge blocker here. If we don't actually have access to people who can help us decide and validate these assumptions, we may be blocked on some experiments. So again, what if we focused early and often on the outcomes that we want to achieve instead of the solutions that are part of the plan? So I advocate include 2 to 4 weeks of discovery and experimentation in your plans, in your forecasts. It's the same as including some time for testing at the end of the build, right? Include time for testing at the beginning. Get specific on goals and be flexible on details. If everyone is aligned on this outcome, whatever the goal is, that's the goal. You know, it's hard to say, nobody's going to dissent about, okay, that's our North Star, that's our outcome, that's what we're trying to achieve. Flexibility on details, because you know what, when we decide that we want to build something and we build it on time, on budget, we ship it. If it's the wrong thing, it's still the wrong thing. That's still wasted effort, wasted time, wasted energy. So it should be healthy, a healthy operating, high efficient team should be questioning all the time. What are we doing? Is what we're building right now the best possible thing to achieve our goals? And then make collecting user feedback a priority. Don't go too long without a user touch point. I often tell teams 2 to 3 weeks is as far as I would recommend going without actually talking to users. So a quick note on finding some people to talk to validate these assumptions. Actual users are best. I tell people, do you have a support line? Is somebody asking for help? Talk to that person right now. They're basically giving you a free ticket. Hey, I'm here and I have opinions. You could also try talking to the people who've more recently signed up for your tool or your service. Someone who's newer to it may have some fresh ideas or opinions. And then I also say, try to publish a blog post or an email communication out to everyone. Hey, help us build what's next. We're looking for feedback. Then I think, try reaching out to people with similar context to your users. Where do they live right now? Is there a specific subreddit where they hang out on Reddit, or maybe a couple Twitter accounts that you might want to partner with? Mastodon is a newer and up and coming social forum. There's also recruitment tools like user testing, respondent.io, user interviews. These tools will help you drill down and find exactly the kinds of people that you're looking to get feedback from. And if you're still stuck, you can't find anyone to talk to, try someone that's just far away enough from your team. Like, do you have operations people in your office that you could go talk to that don't really know a lot about your plan? What about other engineering teams, neighboring people who aren't in your backlog and understanding your work? There's a lot of folks that you could talk to. So when is the right time to consider experiments? When we think we have a new problem that needs to be solved, figuring out all the ways to solve it, that's a time to start to test where we're going. Second, when we notice, when somebody says, I think we've made some assumptions with this plan. I feel like we're assuming that that's going to make sense, or we're assuming that that's the step in the process, but we don't really know for sure. Let's go validate that. And then at the end, before any major new user experience is finalized, we should be testing it. Before we go build it, let's make sure that people understand, we talk about in user interviews, right? Asking, what do you expect will happen when you click that button? Checking to see if they're understanding what really lies behind that button in the design. Let's make sure that their ideas, what's in their head and what's in our plans match. So what assumptions, think about it right now. What assumptions might your team be making? Are there any questions that you think you need to answer next? Could it be time for an experiment? 1, 2, 3, make your hypothesis, make your bets, test it, get it in front of real people. And then number 3, prioritize what works and move forward with confidence in the thing that worked the best. I'm not going to read this slide again to you, but hopefully these steps make a lot of sense. And I'm going to leave you with, if it doesn't work, it's not failure, it's learning. You're saving time and effort and energy. Happy learning. I'll stop there. And I'm open to questions, comments, anything. I can go back and review anything. This is your time.
I think this was great, Kate. I definitely want to take some of these slides and bring them with me when I kind of explain like what wavelength is and how we do things differently. Definitely would like to steal some of these slides to kind of explain it. It breaks it down into layman terms where I think anybody could understand exactly what we're trying to get after.
Yeah, I'll pile on to Troy there. Definitely, as we're working with the wing right now on building I'll say our software onboarding and engineering processes to develop software that we're trying to codify some of this information. This is perfect information to add to our process.
Cool.
I have to say, I thought the example you gave of Theranos was really interesting. I mean, just because their user experimentation, I mean, in some ways, I guess everything they were doing was really user experimentation, since they're basically like vaporwaring their entire business. But I thought it was interesting because like their user experimentation, people loved what they had, but their actual experimentation, they had this big, grandiose kind of planned out plan of what they were going to do, but their actual experiments didn't back up the science behind their product at all.
Totally. I hope everybody's familiar with Theranos, just to make sure everybody is. This is a company that tried a medical system that would take a prick of blood basically and test for 200 plus conditions, symptoms, diseases. As you were watching this, I was freaking out watching these documentaries because I was saying, why are you trying to do 200 things at once? Just nail 1 and then nail 2 and then nail 3.
Oh,
right?
it was scary. And it took so long before it came out that it didn't actually work.
Yeah.
Yeah.
It was wild. It's a wild example, but this is what happens when you just make a bunch of assumptions and drive forward without checking yourself. Anyone have any ideas for an experiment you want to run soon?
Yeah, I would say one that we're going to be doing is experimenting kind of with the fields we have in our Swarm product, on where they should be, what makes most sense. We're doing kind of an experiment with them next week, or the M is the 6/13. AOC some users next week to almost card sort how they would lay out the fields themselves. And so that's an experiment we're going to be running next week, which should be pretty interesting.
Cool. I love card sorting. Steph's laughing at me. Well, I know we'll definitely make the slides available to everybody for after this. And I know we're recording this too, so you'll have that. But if anybody has questions or any other thing, any other resource or example that you're looking for, feel free to hit me up. Kate@growsagely.com. My last name is Macarianis. It's a little wild, but you can just call me Kate Mac. Nick, anything else you want to cover while we're here today? Well, we've got everything.